Hello everyone, this is Bradley. So today this is a voice recording to replicate an animation I found interesting on Twitter. It was actually I found a long time ago, but I don't want to do such a kind of animation that requires loop node. But the loop node will not come anyway in the short run, and since I've done tutorial talking about the loop node, so let's take this as an opportunity to practice how to build a loop. So here we in Blender, let's go to nodings. As always, I'm going to use the presets you can download for free from the link in the description. Let's start with the sphere, but instead of using the UV sphere, I'm going to start with the Ico sphere because it will have a better topology. Another thing that you need to realize is Ico sphere always give you this kind of triangular shape. Here we're going to use the dual mesh node to make it into a hexagon or a pentagon. So basically, it just increases resolution. It will be either hexagon or pentagon, but it will just be good. Okay. So here, there is one thing you also need to know that we are going to mostly changing the color, but it will be very difficult for us to work in the viewport. So here, I'm going to use the normal displacement. On one side, we are going to displace this kind of each polygon. On the other hand, it will be very easy for us to visualize how the attribute is being created. So here, let's plug a directional fold, and immediately you can see there's an area of displacement which is showing 1 according to the maximum, and then the other side which is 0 according to the minimum. And this is how directional fold is being created in this case, and it's on the x-axis. If you change it into y, it means then you have another side at 1, another side 0 on the y-axis or z-axis. So you get a kind of this sort of idea, and you can play around with directional offset to animate that, and or the scale offset to smooth that. Okay. Usually we're working with the object, but in this particular case, I'm not going to use an object. Okay. Because it's not only one directional fold, we're going to create thousands of directional fold for our animation. Okay. In this case, I don't want just a single start and end finish of animation. I want to create a kind of band areas. Okay, so here what I'm going to do is I need to subtract another directional fold with some offset. So let's start with a value to connect with the directional offset. Okay, and plug that in. So immediately, because these two folds are completely identical, so they are canceling each other. But if I add a mask node in this directional offset, then you can see there will be an area left out. And this will be the remnants of a fold that we have created. So you can try to play around with these kind of values and you can see how it goes. Okay, just to know that the larger the values, more areas we have been covered. This is kind of important, and here let's just smooth that out a little bit. Just remember that ideally speaking, they should be identical. So however you change, you can use a single value node to plug into the scale offset, and so on and so forth. It's completely okay. It's up to you, and you can animate it. And this is the animation that we're going through. Okay, here I just want to do a multiply just to try to scale down these values a little bit, but I think this will be fine. Okay, so once we finish this, then we can start to do a loop. Here I also forgot that before we do the loop node, I'm going to displace the polygon inside of all these kind of vertices, because by default we're working with the position attribute, which is the vertices location. But here, I'm going to use the attribute mesh info, which is basically a split edge nodes plus some capturing attributes at a different domain, like a face domain, so that we can obtain the polygon center. So here I'm just going to plug the polygon center, and immediately you can see we're displacing the polygon inside of vertices. So they're straight out away. Okay, and this is the, and here I'm going to hit the Control G because I no longer need other sockets. Okay. So this is the group which is ready to go for a loop node. So let's just select all of them. Okay, and hit a Control G. So they're in a single group node. We can call that animation unit. the name does not really matter. You just need to know that the whole goal is that in the future we're supposed to duplicate all these kind of units over and over again to achieve different effects. Okay, so that's the idea. So here, let's firstly go inside a loop node. As I've explained in my loop node tutorial, the most important part of a loop node is not the geometry, it's not a custom vector, but rather the loop index. Okay, the loop index node is having a single integer index input and a single integer index output. So you just output that. But here I'm also going to output these custom vectors out. Yes. So you need to make sure that you always have comparable inputs and outputs. This is very, very important when you construct a loop node. And here it looks kind of dumb because I have a node which is doing such a stupid job. Why don't I just connect the index out? This is because this loop index node, it actually contains just a single math node to +1 every time. So that when you're duplicating this node, you know this is the first node, this is second node, this is third node, this is the fourth node. So that's the whole point of this loop index node, as you can see. There are definitely other options, but we're not going to take care of them because we are not going to use them. Okay. So next is to try to deal with different loops, knowing that we are not only going to displace every polygon, but we also need to do the color changes. And in order to change the color, we have to output our attributes to the modifier, which means output the attributes outside this group node, and into our last group output. So here, let's just plug this fourth subtraction out. So let's name that as just to say the fourth. And remember, as I've mentioned earlier, that we always need to make the input and output comparable in a loop node. So here, I need to increase another fourth. Let's just take a float. And let's name that as a 4. Okay. And every time I have to add these 4 together, it's basically a way to join the 4. Okay. So this is the basic part, and there is a next part I would like to do is to rotate this entire directional 4. Okay. The rotation here is kind of pretty simple and straightforward. What we do is just to use the vector rotate. And by using the Euler rotation, as you can actually see, it's not a very, yes. So right now you can actually see by rotating this Y, you can see the evaluation has been changed. And here I want every time this loop is generate a different orientation. So I'm just going to take a random rotation because I have a preset. But in reality, you also need to know that the random rotation is basically just a random value node plug into a vector, and you can type in TAU, which means 2 pi, in the sockets. It's basically doing the same thing. Okay. Okay, so here I'm going to use this random rotation, and you realize there is a problem. We will discuss this problem later. It's basically because of this ID in the random value, which is working on every indices or vertices. Okay. But in this case, we're going to use the loop index so that we only generate a single value every time. Okay. And I think this is okay. And now if we go outside, we can try to look at our outputs. Just to know that the results will be very likely horrible, and I will discuss why. So we duplicated this animation unit for several times. I think this is good enough. And we select all this kind of animation unit and hit F. It will automatically link everything together. This is the major reason why we have to make a comparable input and output so that the value can be shared across with all this kind of FFF. And let's hit that. And this is how it looks. Looks kind of very crazy and ugly, and this is not an animation. But to me, it looks like we get our result right. You just need to manipulate the... Actually, this is also very interesting. But instead of this kind of chaos, we're going to animate that inside the loop. So to make this into an animation, we're going to use the delay Falloff. Before we actually start to work with the Falloff, I would like to know the values that to make this animation start and the end. As you can see, it's about the positive minus 1.6. Okay, so let's start with the delay Falloff. Delay Falloff normally works on the index. If you directly plug this Falloff to replace it, it should be chaotic. It doesn't, but anyway, I don't think it's a good sign. So the whole point is we're going to use the loop index to replace the custom index, which is a field working on every vertices. Right now, we do not have any changes yet because we're working on this 0. Okay, this 0 is very important because previously we've already known that this Falloff should working in the area of positive minus 1.6. So let's just go with a negative and plus this original as a 1.2 should be fine. Okay, and by playing this animation on the timeline, we can actually see there is something which is scrolling very fast. So here we need to deal with some parameter within this delay Falloff. The step interval means how much interval from index to index. So let's just set that to 10, and the duration will be, let's just say the 45 for now. Okay, so right now actually I'm not going to use the initial index. There's no real difference, just to know that the initial index starts from the 0, but the index after loop index starts with 1 because every time you plus 1 inside. Okay, so that you will not have a delay in the middle. So now we have this animation. Let's increasing this step interval further so we can see this animation more clearly. Okay, so let's start with this, and you can see there's a Falloff, come and goes, Falloff, come and goes, Falloff, come and goes, Falloff, come and goes, come and goes, come and goes. Okay, so this is basically our animation. So you can deal with these parameters. We will go back this later, but I think right now this looks kind of okay already. So here I'm going to output this attribute, this Falloff. Let's just name that as color, as a C. So here let's take a set material. Let's add an material so we can use the emission shader or whatever stuff. So goes to the shader node, and I'm going to use the attribute node to take this attribute, which is C, and we can use a mix RGB. So one is black, and the other is maybe blue or whatever other colors, and then we can use the emission shader. So if we go to the material preview, it will take a little bit of time to calculate, and let's change the base color a little bit. So now we have this color thing occurring as well. We can turn on this balloon so that it becomes much more interesting. Something like that, and you can see this animation. So let's just start from 0, and we can play this animation. It takes 45 frames to finish an animation. So we have 1, we have 2, we have 3, we have 4, and basically this is the idea. Okay. So this is the basic setup. Definitely there are more things we can do. This means you don't necessarily follow what I'm doing later because it's rather kind of optional in my opinion. Okay, so the first thing I'm going to do is I realize there is a problem if you are setting the camera. So here I'm setting camera in the 0, which is on the y-axis. Okay, and if you play this animation, you realize some of the wave is coming from back, and you realize this is very bad. because you don't clearly see what's going on. So I'm going to try to tweak some settings. For example, I'm going to turn this directional Falloff onto the y-axis, and instead of a full degree of rotation, so right now without this random rotation, it always comes from the front. And then now if I add a little bit of variations, does not need to be a lot, maybe half of pi, then you can see it always comes from the positive side, roughly. So let's decrease the variance here a little bit. Okay, and definitely we can also tweak this subtraction so that to decrease the amount. We can also try to change the subdivision so that the more polygons we can see. Okay, so these are all things that we can do. There's another thing which is very important when you're trying to make an animation, that you need some trigger. Otherwise, if you directly have this kind of visual effects, it seems to be something is off. Okay, it will be more realistic if we have some trigger. So I'm going to start with a cylinder, and we have to output all this kind of cylinder. So let's add a geometry. So let's name it as a loop input. And as I said, you always need to have a comparable input and output. So let's add a loop output. Okay. So let's output this cylinder, and we can go outside. So for now, I'm only going to look at a single loop, okay, so that I can transform my cylinder. Let's rotate at 90 degrees, and let's decrease the radius so it becomes a long stick, and let's decrease the depth. And we're going to do the transform on the top of these all the transform. So just to duplicate another transform for the effect. Instead of rotating 90 degrees on x-axis again, I'm going to use the random rotation, which is similar for our vector evaluation of the directional Falloff. And you will see this kind of red line warning. Usually it means very bad things. It means error. Okay, you are not supposed to put all this kind of dash line into this solid circle socket. Okay, but this is inside a loop, and if you really think about that, what we're having here is actually a single value, which is 0, and you plus 1 every time. So this is more kind of illusion, because this is not supposed to be actually a dash line. And regardless, you still see the effect, okay? And the next thing is we're trying to translate on local axis. But for the transform node, it's a global axis. So I'm only moving on Y. So here I'm going to use another preset, which turns the rotation into vector. So it's called a rotation to vector. Yes, rotation to vector. And I plug the rotation in. And by default, it's looking at the z-axis, which I think will be fine. So here, no, it will not be fine because we're looking at the y-axis. So yes, right now if you try to change the scale, then it's good. Remember, the 0 scale means it's not moving, but the negative scale it means it's moving. Okay, and next, so now we have 2 red line. Again, this in normal cases this means error. I'm not encouraging you to do that, but in this case you can see it's working due to some specific reason. This also tells you that in the case that you want to have a variation of your instance due to whatever reason, for example, you want to deal with this kind of a cylinder, for example, different segments, and if you normally plug that, you will have this kind of red errors. But if you're doing that in a loop, then it will be legit, okay? Even if it tells you the opposite, but it works. So this actually tells you how important the loop node is, but we do not have a loop node. You have to construct it by yourself. Ha 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 ha. Next, we need to animate that, and of course, we need to use the delay Falloff. And knowing that these two animations, the stick animation and the deformation of our icosphere, are related to each other. So it's kind of a delay on the top of a delay, something like that. In this case, I'm not going to use the 2 delay Falloff, because if I delay one, the other must be delayed at the same time. So here, I'm going to change the setup a little bit. That I'm going to use the delay Falloff connected to the scale and cancel the initial delay Falloff. Okay, and I'm going to cancel this negative because moving this stick, as we know, the value goes from a large negative value to something like 0.-5, I guess. We will see later about how it actually affects our sphere. Okay, so what about the second delay with the formation of our icosphere? In this case, we're going to use the time, so map range. So this time is the time that's after subtraction of this kind of duration, which means this time will be counted as 0 after one action is being finished for our Falloff. In this case, this for our maximum will be the duration. So let's type in maybe 50. And this minimum and the maximum will be our effect or the Falloff that we created. So in this case, well, let's just take the negative and the original. Okay. And let's plug the results inside. So now we should have everything being done properly. Okay. We can go back to our geometry nodes outside of this loop node. And we can try to see our result. And the result will be quite simple. So you have to join geometry, to join the icosphere and the loop outputs. And of course, we need to set the material. So now we should be able to see our stick and the animation at the same time. So we have the stick, and by playing this animation, you can see there should be animation being triggered after. Here you see the animation starts about this location, but the stick was on the opposite direction. This is kind of very interesting. I do not want to deal with too much mathematical thing, but it's for some reason that although they come from the same rotation, but one should be opposite, as multiplied to be -1 for the directional Falloff. So now we should have the stick and animation at the same place. Yes. Okay, this is good. So I think this is good to go. At the end, we just need to join geometry, so that we'll join the loop input every time when we add a new stick. And let's revive the new loop. So after so many loopings, let's cut them out and let's unmute them. Select all these kind of nodes, hit F, so that they connect the loop output to the inputs. And finally, just join geometry. So you have multiple stick and the multiple animation. And you play this animation, you can see the stick, the animation, stick, another animation, stick, animation. So eventually it's just about the tweaking all these kind of values, but I think this is good enough. So maybe take that to 1.6 and maybe the duration, step interval, so on and so forth. And we can try to see if it's I think -0.5 is a good number. Well, we just need to trigger the animation a little bit earlier. So maybe 1.4. 1.5, something like that. So I think this is it. By the end, eventually it's just about the tweaking of this kind of value. Although by the end, this node tree looks kind of complex, but I hope you can understand that. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.